Hi, Assalamualaikum. My name is Amir Faiz bin Muhammad Suhaimi, CF1800097. Today I will talk about the introduction of the vane shear strength. The shear strength of soft clays can be determined in a laboratory by a vane shear test. The test can also be conducted in the field on the soil at the bottom of borehole. The field test can be performed even without drilling a borehole by direct penetration of the vane from the ground surface if it is provided with a strong shoe to protect it. The vane shear test instrument consists of vertical steel rod with four thin stainless steel blades or vanes fixed at its bottom end. The IS code recommends that the height of the vane should be equal to twice the overall diameter. The diameter and the length of the rod are recommended as 2.6 mm and 60 mm respectively. Vane shear test is a simple and quick test which can be performed either in laboratory or in the field. It is cheaper and quicker method. The laboratory vane shear test for the measurement of shear strength of cohesive soils is useful for soils of low shear strength less than 0.3 km per centimeter cube, for which triaxial or unconfined tests cannot be performed. The test gives the undrained strength of the soil. The undisturbed and remolded strength obtained are useful for evaluating the sensitivity of soil. A vane shear testing equipment consists of four thin stainless steel rectangular plates called vanes welded orthogonally to a high tensile steel rod. A top measuring arrangement such as calibrated torsion spring is attached to the rod, which is rotated by some arrangement from the top. Thank you.
Okay, my name is Tay Switching. So today I would like to present about the objective for our project. The vane shear test is conducted to find the shear strength of cohesive soil. Is useful for low shear strength soil which is less than about 0.5 kg per centimeter square. This test gives the undrained strength of the soil in both undisturbed as well as remote condition. Vane shear test is a cheaper and quicker method of measuring of shear strength of clay as compared to very elaborate triaxial shear test or direct shear test. For the apparatus for vane shear test is first we need to use the vane shear apparatus, specimen container and vernier caliper.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mukris bin Muhammad Hatta. I will be presenting the procedure. Now this is the procedure for the vane shear test in lab. So first of all, before conducting the experiment, first we must measure the height of and the diameter of the vane beforehand. Now for the test, undisturbed sample is used and it is molded into a proctor. Now make sure the apparatus runs smoothly. Now this upper handle is used to move the apparatus up and down. Place the specimen in the apparatus. Now lower the vane apparatus by turning the handle anti-clockwise until the top of the vane is at the depth of 10 to 20 mm in the specimen. And then record the initial reading. Then apply torque to the vane by turning the handle at a rate of 0.1 revolution per second. Now when the specimen fails, the strain indicator will move backwards, then record the reading. And repeat the procedure for 2 more samples and calculate the average.
Good morning to our lecturer, Dr. Nasir, and my fellow friend. Today I will present about findings. So our findings, the laboratory vent shear test for the measurement of shear strength of coarse soil. It is useful for soil of low shear strength. This means we are the specimen for the vent shear testing are suitable for soils who have a low shear strength that is less about the 0.5 kg FCM square. So this test gives the undrained strength of the soil in undisturbed as well as removed for condition for both. Okay, so they use the undisturbed soil, okay, for this specimen, and this is the example of the vent shear test table. These are the example, and later my friend Sia will be explain about the result, the sample result that obtained, the sample result, and my friend Ashraf will explain about how to calculate this table. Okay, so I will explain a bit more about this table. So SD number is a sample number. There are 5 samples that will be taken with initial reading and final reading. So we taken for this test is we obtain the initial reading degree and the final reading in degree format, and then we will compare both the final and initial to obtain differences, and then we find the torque, and lastly we will find a spring constant for the soils. Okay, so I'll pass the explanation of the formula to my friend Mr. Ashraf.
Assalamualaikum and greeting to Dr. Nasir. My name is Muhammad Ashraf Yazmilan, CF 180111. So I'm here to explain the formula we use in our lab. So for top formula, we use for top formula, we use this formula. Difference of angle multiply by spring factor divide by 180. So you must complete all the column here, then you find the G1. So G, we use this formula. 1 divide by pi multiply by diameter square times height divide by 2 plus diameter of vein cube divide by 6. So all the diameter and height here, we use the diameter and height of vein in centimeter. So then you can proceed to next table. S is shear strength. So for shear strength, we just use basic formula. Top multiply by G. The calculation we got before. Okay. Then after you complete torque, G and shear strength, you just calculate the average. So that's it for our lab. So thank you.
Hi, my name is Xia Xiaoyao. Matrix number is CF180010 from Geotechnique Session 1. Now I will present about the finding for the windshield test. And first, I will present about the advantages for the windshield test. This windshield test is very easy and quick, and it can perform in lab or field directly on the ground. And now it has the 2 types of apparatus for the windshield test. One is generally the windshield apparatus is testing in the lab, take the sample from the field and testing in the lab. And another apparatus is the handheld wind shear apparatus. It's easier to test the strength of soil, and it is lightweight and easier to take to the field to testing the soil directly. And next is the in situ wind shear test, ideal for the determination of undrained shear strength of non-fissure and the fully saturated clay. Next is the wind shear test can test the shear strength of soft clay at greater depth. And next is the sensitivity of soil can determine using the wind shear test result of undisturbed and remote soil sample. The formula for the sensitivity is the undisturbed divided by the remote soil sample. Next, I will present about the drawback of wind shear test, which is the disadvantages of the wind shear test. The wind shear test is not suitable for clay which contain the sand or silt lamination in it, and it also cannot be conducted on the fissure clay because the fissure clay is dry, cracked, and have many fissures. It cannot to use to determine the wind shear test. And if the failure envelope is not horizontal, the wind shear test does not give the accurate result. Next, I will present about the sample data of the wind shear test. This table is one of the sample for the wind shear test lab result. From the table, we can see it has the initial reading, final reading, difference reading, spring constant, torch, and the average shear strength. So for the first step, we must collect the data for the initial reading, final reading for every sample that we take. And second is find the difference in reading, the difference between the initial reading and the final reading. Next, we will use the difference in reading. We find the spring constant and the torch. The formula for the torch is the difference in reading time the K divided by 180. After calculate the torch, we will use the data for calculate the average shear strength. The formula for the shear strength is S equal to the torch times G. That's all from me. Thank you.
Hello, my name is Ken Aljosh Nalawin. I'm going to present about our conclusion. Okay. When shear test is used to measure the shear test strength of soil, it is also estimated and measured the fully saturated clays under drain shear strength without the range in the specimen. These tests can be conducted in the field and laboratory. However, in laboratory, it can only execute the experiment with slow shear strength of 0.3 kg over cm square, for which unconfined tests cannot be performed. The test apparatus are composed of 3 different diameters of 4 blades. Stainless vane is attached in the steel rod that push vertically in the soil. The pocket value that can get in a small vane should be multiplied by 2. However, the value that can be get in large vane should be divided by 2, and the value that can be get in a medium vane is as it is. The test is performed by pushing the vane vertically in the soil and rotated in clockwise from the surface to determine the torsional force. The soil will be resist the rotation of the vane, and its resistance is the force of soil that causes the cylindrical area to be sheared by the vane. When the rotation of the vane is continued, it means that the soil fell in shear, and it is normal that the rotation is continued that after measuring the strength of its shear.